Hello, welcome to stream number 40 in this series of streams where I am programming an NES game live on Twitch, Mondays and Thursdays, 9 p.m. Eastern. Thank you for joining me on this very steamy New York night. One quick announcement. So in case you didn't notice, on the YouTube page I've started posting what I'm calling the Zero Page series, which is essentially shorter videos that go over some of the stuff we cover in the streams. So the streams are obviously much longer. I'm going to try and keep the Zero Page videos to about 10 minutes, covering different topics related to, programming and NES programming specifically. But if you have any topics you want me to cover, feel free to let me know, and I will do my best to cover them as well as possible in about 10 minutes. I find that people seem to like the shorter videos for, looking up information, and the streams are kind of a more in-depth view. Last time we were working on, the last two times we were working on getting the attribute updates working properly so that our map, which is supposed to look like this, trying to get that so that the colors actually look like that as we scroll through our meta tiles. And we are close. So if we go here, we were having some issues with the updates not being 100% correct. So I wanted to try and get that taken care of, and we'd found that, contrary to what I was expecting initially, doing an update of the attribute memory in a complete update seems to be faster than me attempting to only update the parts that we changed in our memory, which was very counterintuitive, but just based on the numbers we were seeing when we were looking at the cycle counts, that ended up being a lot more efficient. And you could chalk that up to, a number of things. It could be my code was inefficient in trying to determine where it should be updating. It could be the all the branches and evaluations that were necessary were too lengthy and causing us to take too long. We're still taking too long somewhat because you can see this jitter as we scroll, where the status bar jumps a line, and that's indicative of taking too long in our updates. The other thing is somebody mentioned on the Nintendo Age Discord, I think it was, a bunch of people were recommending it, but there is an emulator called MESEN, which I hadn't really used before, and it has a problem with my game, but that's because of something I'm doing wrong with the MMC3 mapper. But it is pretty cool because the debugger has keyboard shortcuts. The whole thing seems to be way more focused on development. So there are all sorts of shortcuts for the keyboard. So stepping through uses F10 just like in Visual Studio. Probably F5 runs just like in Visual Studio. Let's see. Yep, continue. So the person developing this goes by the name Sour on Nintendo Age, I believe. But this emulator is, leaps and bounds beyond what FCEUX was giving us. So I think we're going to switch to this, but not quite yet, because like I said, there's a problem with the way we're using the mapper. And so our sprite memory over here, the sprites are not quite correct, and so we're not seeing the ship over here. So let's get the attribute stuff, let's get the attribute stuff working properly, and then we can mess with MESEN, because I think it's totally worth it given all of the stuff that it has built into it. I even saw that apparently you can load in your debug symbols from CC65, which is totally banana cakes, because if we can do that, then we don't just see these memory addresses anymore. We actually see what's going on in our code. So let's focus on one thing at a time, because I could easily spend the whole stream messing around with this. So one of the things I was thinking of doing was changing the way that we were doing this code here, or using the mode split. And the reason I say that is because I realized that we could probably save ourselves some time by doing the following. So if do I have to do this like this? Will that compile? No. Is it automatically assuming hex? No. Okay. So what I want to do is I want to use the split attribute mode to determine how we're going to mask the byte of the attribute, and then only do some processing for the previous row if we need to, because we're in the split mode. So what we had been previously doing was we were selectively choosing, we had our one row, right, of the meta tiles, and we were selectively updating the attributes of the meta tiles and saying, okay, we have to either update those and then update the one from the row above, or we have to update the entire thing. And we were doing two completely different code branches and doing all sorts of specialized logic. And what I realized we could do is we could use the mode to determine, if I do this right, we could use the mode to determine how we want to update that memory. So let's do a check here. So the only thing that we need to do that is going to change is we can't use bit number 2 anymore for determining if we actually updated, if we've swapped to another metatile row, because we need that bit along with all the other bits to mask our attribute value. So what I'm going to do is I'm just going to create another variable for now. We'll just call it metatile flag. Will just be a byte. And then, so we set that there. We want to process scrolling, load A, and store A. Okay, so here's where we're setting that bit up, or potentially zeroing out the bit number 2. If we had set it previously, we don't need to do that anymore. What did I call it? Metatile flag. So we'll just zero out metatile flag. And then if we get to this point, we just say and I realize it's wasteful to be storing this one bit in just a byte like this, but right now I'm more focused on getting the code working, and then we can, you know, start looking at once we have code really working the way we want, we can take a look at how our zero-page memory is laid out, and if we're getting issues with if we want to more tightly pack the memory, we can do that. But as I've said it numerous times, try to adopt an approach that's simple to start out with, because if you try and make it complicated to start out with while I'm still learning what I'm doing here, it's more likely that I'm going to screw this up. So metatile flag. Why are we ending this with 2? We're checking. Okay, so we're just compare to 1. Branch not equal to done with attributes. Then the flag wasn't set. We don't need to do this. All right, so compare the mode to, so now we get to save this part because we don't care about this anymore. What we want to do is we want to just split based on attribute mode. So right now, the reason I'm doing this is as follows, right? So if attribute mode is set to split, then it's 0f. And so whatever our attribute value is, because the asset converter tool is storing the attribute packed ahead of time. So we have our bit values stored in the, there are the 4 nibbles here in the I'm sorry, no, there are the 2 nibbles here in the byte, storing our values of wait a minute. Yeah, because this is 10 10 10 10 10 10. Yeah, so sorry, the 2 bits are for each tile, so this nibble is for the part of the meta tile that we're trying to populate, right? So we're either trying to do an entire 4 quadrant, which looks like this, right? The real tiles is you have 4x4 tiles, but this is further divided into these 4 sections where you have the 4 tiles, 4 tiles, 4 tiles, 4 tiles with the same palette color. So we're either trying to do half an update in one row and half an update in another row, or we're trying to do the whole thing. So I'm trying to use this split mode mask to determine how we not only how we handle the update, but also as the mask, so that we can, for the first updates, we don't even have to check and branch. We just do the operation where we AND the attribute mode against the value that we've loaded from this location, and then we store that into the attribute buffer, and then based on the attribute mode, then we can branch. So we can get rid of this because this is no longer necessary. So okay, we're loading our attribute value. And then the attribute mode, store it while we get the attribute value from our buffer. So now that's load the buffer, load the attribute index. So that's where we're at in the attribute buffer that we're getting the attribute values from, because we have our separate map of the attribute values. Then get the current attribute values, and then we don't need to do this part, do we? We do. Wait. So this is us clearing out the bits so that we can kind of mix them in. So whatever the current value is based on the attribute mode, if we're splitting, we'll have 0F, which means we'll only have the lower nibble populated. Otherwise, we'll have the upper, we'll have the whole thing. Should we, let me see. So should I be doing, so get the attribute mode, flip the bits using exclusive OR. Let's see, because if we have keep hitting the button on the stylus. So if we have these 4 bits set and we do an exclusive OR, we're going to get 1 1 1 1 0 0 0 0. So we'll get the flipped bits. Right? Yeah, that's right. Okay. And the mask is always ever going to be that, and then we do the AND across that, and that would be okay, because in the case where, yeah, so, all right, so sorry, because I'm like thinking about this and trying to explain it at the same time. So we load our attribute value, we're going to AND it against the attribute mode, which in split mode will drop the upper 2 bits, the upper 4 bits, and then we're going to store that off. Then we're going to grab our index into the memory. We're going to transfer it to X because we're going to use that as our index into the memory. We're going to take the attribute mode value again, and we're going to flip the bits on it, because now what we want to do is we want to use that to remove bits from the buffer value. So if whatever the buffer value is, if we're replacing only half the bits, we want to zero out the opposite bits that are being set by this operation that we're doing here. Or if we're setting all the bits, it's okay that we're zeroing out everything. That's effectively, that's what we want anyway, because then we're going to do the OR, and if it's 0, then we're just updating the whole thing. So that should be okay. And then we're going to store that back into the attribute buffer. Let's see, we've updated the one attribute at that position now. Okay, so now this is where we have to check the attribute mode to see if we need to do anything. So we load attribute mode and compare it against against split and branch if not equal to done with attributes. So we've simplified this in the sense that we only jump after we've done either a full update of the byte in the attribute buffer. We don't have to jump regardless, like we were before, kind of skipping over sections depending on what mode we were in for updating the attributes. And then if we are in split mode, then we want to do what it says here. We want to transfer X to A, and then we want to go back to the previous row compared to where we were. And then we want to roll it over if we've gone either off the 0 end. So if we've subtracted too much, well, that's the only case because we're doing subtraction, right? So if we've subtracted too much, let's say we were at a value of 4 and we subtract the 8, then we're going to get a negative number, and doing this AND will put us back within a 0 to 64, 0 to 63 value, which is what we want. And then we put that back over at X. We load the attribute again. And then we're going to do our AND to zero out the bits here. And then that means that split mode is actually flipped in this case. So let's see. So, or the attribute mode rather. This is fine. That looks all good, and then we don't have to do a jump there because we're there. All right, let's see. Let me close this because we know that's not going to work right now. I'm anxious to get to MESEN just because of what it seems to offer in terms of development. It looks like it's going to be helpful. It apparently has some really cool features for debugging splits. Which is not an easy thing to do if you're doing multiple, and we're only doing the one for our status bar, but you know. Okay, well, the good news is this is better. We're not getting the status bar jitter that we were getting before, and it looks like we're only off every once in a while for the colors. So this is definitely an improvement, all in all. Let's go to our Lua for profiling here. Let me slow this down. Yeah, oh wow, that's way better. So, I mean, it still could be better than that, but we're hitting about 2100 cycles for the NMI where we're calculating, where before we were lucky if we were making it in under 2700. It's still not great, but it's definitely way better, and that's why we're not getting that status bar jitter that we were getting before. So by being just a little bit smarter about how we were doing these updates, it's happening a little bit more efficiently. That's pretty cool. Alright, so now we just got to figure out why it's off, like why the colors are not getting updated quite right, because the color that blue come on, the color that those blue tiles should be is this dark blue and not the purple. The purple, you can see it here where it's wrong. That purple is the color from these gradient tiles. So, why? Let's do this. Let's restart this. Let's slow down the emulator and let's take a look at what it's doing here. Damn it. Okay, so the first, okay, interesting. So the first row that we update is actually, is that the first row or is that the second row? It looks like maybe it's the second row. The second meta tile row, we're not updating the attributes properly. And, okay. We're just off. We're really close because we're only off by, it looks like, one row of meta tiles. So this is correct, and then we have this, which is wrong, but this is correct, and then this one is wrong. But if we shift it down, it'll be fine. So what does that tell me? That tells me that we are messing up. Messing up how we're doing the updates a little bit. Let's see. useful. Let's see. Let's take a look at the PPU memory here at 23C0, which is where we're doing our updates for the attribute memory. 23C0. Let's refresh. It's one area where I wish I could use multiple screens, but when you're streaming, you can't really do that because you can't. I don't think you can stream multiple screens at the same time. All right, hold on a second. That was a much faster update than I wanted. I wanted the emulation to be much slower. Okay. Okay, so we're paused, and this is our first look at the attributes here. So this is going to be, that's our 64 bytes, right? And oh, I'm not. I always do that for some reason when I'm streaming here. I always forget. I guess it's because it doesn't have the spacing. I always forget the hex has the 2 digits instead of just the 1. Okay. If I could resize this so that it would align the way the screen aligns, it would be easier. But anyway, so if we look at the screen here, we've got our first row of meta tiles, our second row of meta tiles, our third row of meta tiles, the next 2, then this one, and then 2. It's really 1.5, right? There's the status bar. The status bar is there so you can't see it, but there's this 1 row, and then there's a half row that we're not actually using. That's 16 by 32 tiles. What am I saying? 16 pixels. It's 32 by 2 tiles. It's 2 rows of 8 by 8. So if I unpause here, we populate the first set. Let's take a look at the attribute memory. That shouldn't have changed. It doesn't look like it did. Update the next row. We're good. So it didn't update the attribute memory here, which is okay. Or we didn't see an update. I wonder, and then we hit our next meta tile row there, and did it update it, or did I miss it? No, that looks right. It looks the same. Oh no, it's no, it's the same. Okay. All right, so keep going. So it didn't update the attributes there for that row. Wait, why isn't this updating? Or is it? And I didn't see it. I see the tiles updating. I don't see the attribute memory updating. miss something? Oh, did I? Oh, son of a gun. I think I know what happened. I think I may have disabled the code. Damn it. Here I am talking about how good a job I did, and meanwhile, I may have turned off the update. Oh no, it's doing it. Okay, right? Or is it the check is wrong? Okay, the check is wrong. Alright, well, that's not so bad then. It's still not updating it, but... Well, that was stupid. Oh, that's not what I want you to check. I want you to check. This is what happens when you take a whole week off. Load metatile flag, branch not equal, branch. So if the value of it is not 0, it won't be, it's considered not equal. So you have that. And all right, let's see what happens now that we're actually updating things. It's probably gonna, yeah, it has the jitter back. Damn it. Well, I feel less good about this now. Oh man, this attribute stuff. Well, at least we're seeing the attributes get updated now in memory, even if they're not exactly right. So, all right. Oh. Let's see here. When we get the first set of updates. Oh, okay. Is it updating? I guess it's updating the wrong location, because why did it update that? Did I not load the attribute index properly? I can just do this. Yeah, it's loading the attribute index. Did I change the initial value incorrectly? No. It should be 38. I'd really like to work on something besides attribute updates. I'm sure you'd probably like to see something besides attribute updates too. Okay, so why is it loading this row of attributes when realistically we're at this point? So it shouldn't be that. It should be, let's see, if this is this is a half attribute row, so it would be updating 38, and that's bizarre. Let me set a place we're going to trigger a breakpoint here. what our values look like here when we're doing this. So step over, and then we're gonna, okay, cool. So this is the spot where we're supposed to be. So loaded the attribute value into A. Oh, is my, I have that reversed, don't I? Wait, do I have it reversed? The top left is our, okay, so it's the lower, so I do have that reversed. So that should be that. And then that's okay. And then the bottom is the lower, is the upper 4 bits. So if we are in split mode, then we, let's see, we want to take our row mem value and it, and then that, yeah, okay. Because we only want the upper bits. Okay, let's see if that has any noticeable improvement. All right, so step over, load that, and it with that. So it's 0F because we're in split mode, so we want to do the top left and top right first. We're going to store that. Then we're going to load our attribute index, which is 38. We're going to put that into X. Then we're going to load A with attribute mode. And then we're going to flip the bits. And then we're going to AND that with the attribute X value. And then we're going to do an OR with the value of temp2, which is also 0. And then we're going to store that. It doesn't highlight. I want to. So you can't. It doesn't highlight even if it's overwritten with the same value. But let's see. So 23C0, which is the base address. 23C0. Oh well, that won't get set till we. That won't get set till we actually do the copy over. Let me see here. Our attribute buffer is in the beginning of the 0 pages. So okay. Let's go back to the hex editor and look at the NES memory. Go to the beginning. Okay. So step over. We'll compare it. We'll branch if not equal. All right, good. So now we're going to subtract 8 to go to the previous row. We're going to AND that value, which is going to do nothing in this case. We're going to transfer back to X. We're going to load the attribute value. We're going to AND it with F0. Then we're going to store that, load the buffer value at that location. We're going to AND that with 0F, and then we're going to do an OR of the two, and then we're going to store that back into the buffer, and that's not showing any update, of course. And then we increment the attribute index. So that looks like what I want it to do. Once we let's see, increment the attribute index, we load the attribute index, and then we mask it, or we make it wrap to 64, and then we store it again. Then we increase y and we compare it, and then, yeah. So if we're done with our meta tiles, then we're going to, yeah, we're going to change the section in screen memory that we're updating. And then once we're done, let's see. So that load a branch not equal, load a branch not equal jump. It store a right above that, probably. Then that's load a attribute index. Yeah, so this spot I want to put a breakpoint here on this execute. So let's run that until we get there. Name table. So we've loaded up the first section. Yeah, so it's updating the wrong part of the attribute table for some reason. It like updated here and here instead of here and here. Well, I would have done that. What is attribute index set to? Another reason why having symbols would be good for the debugger. So I don't have to keep moving my variables around to find them easily in the hex editor. It's 38, 30, 30, 38 again. 0. Whoa, 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 whoa. That's not okay. So it shouldn't be doing that. So it should be going down sequentially. So what we should be seeing is, do I have a calculator open? So what we should be seeing is it should be 38, 30. Then it should be 30 again in split mode, and then 28, and then 28 again, and then 20. So let's see. So we're incrementing attribute index once. Incrementing the attribute index at the end of, if we're done with the attributes. Oh. Well, that would explain some of it. Well, actually, would it? For yeah, so we shouldn't be doing this. This actually should be called, we'll say, this should be skip attribute code, or skip attributes. So this is, we're like actually done with the attributes, and this is skip attributes. So we were incorrectly modifying attribute index unnecessarily. So that wasn't helping things. Do I keep closing these windows? That's really annoying. Name table viewer. Debugger. Okay, let's see if we start seeing some things that make more sense, like the hex editor, the values being updated in the attributes in the locations that I expect them to be. Yeah, okay. Well, now we're getting something that makes a little more sense. And that looks right. That doesn't. But that does. Okay, well now we're actually doing attribute updates, and it seems like we're off a little bit here, but it looks like we're only updating. Looks like we're only updating the lower portion of the attributes for some reason. Okay, well, that's still better than what we were seeing before. So let me pause this. Are we not doing this properly? So now, let's see. So if we're doing a non-split update, then we're done and we just add to the attribute index. That's fine. For this, that's fine also. So that means we've increased by 8. And then we are over here, and if we are in a split mode, okay, so for, no matter which mode we're using, oh, that's the problem. We're using the old split mechanism, so I don't want to alternate. That may be the issue, is that we're not switching back and forth between the split and the non-split update. So let's see. If the mode is 0F, oh yeah, we just do this. We just do the EOR on the top 4 bits, because that's what we want to use for this. That's what we're using to determine the split or no split, right? So it's just this. And then, all right, let's see. Let's see if that did it. Did something. Let's start from the beginning. I want to watch these attribute updates. They should be going kind of in a row. It's still not updating. It's still not updating anything lower than or above. So what gives? So if we're updating, we're subtracting with carry. Right, because let's see. So if we were at 38, we're adding 8, so then we're going to subtract 16, which gets us to the next row that we need to update, which is 30. And then we're going to end that with 3F. That shouldn't, I don't think that would have any effect on the flag, but let's take a look. Load a 38, set carry, subtract 10 hex and 3F. And then let's look at what the carry looks like at the end. Symbol run. The carry is set. Branch carry set update attribute PPU. Right, so we didn't flip over. And then we're at 30. I'm going to assemble and run that. And again, it should only happen if we're like at 8. The carry would be clear, right? And we have 38. So now the carry is clear. So we load the attribute mode. We flip the attribute mode. So if we load that with F0, and then if it was 0F and we EOR F0, we should end up with FF, and then if we had FF and run it, we end up with 0F, which is what we want. So then we store that back, and then we compare that with the split mode. And if we are now in split mode, we want to set the index to 38. Versus 30. That should be okay. I still don't understand why we're not seeing updates to the attributes lower than that location in memory. Should be walking it back, so we should see updates to here and all the way up, and we're only seeing these last two meta tile rows getting updated for some reason. What's with the arbitrary capitalization and labels? I don't know. Sometimes I like to capitalize it. let's see what the value is when we actually do the subtract here. I expect that we're going to see that it's not the range of values that we were hoping, but that's what I want to pinpoint here. Okay, so that's going to load the attribute index, which at this point is the value that I expect. Wait a minute. Load a. That's not the value that I expect it to be. That's the address I expected it to be. Or, no, that's the value that I expected it to be, but not the address that I wanted it to be loading it. Oh, I guess it's just a coincidence that it happens to be. That's right, because it's coming after. It's at byte 64 in memory. Okay. So, why would it be 0? It would be 0 because when I am incrementing it, I am then, yeah, so then I'm doing the AND roll over here. So when we hit 64, it becomes 0, which isn't wrong. So now if I set the clear and subtract and then roll it over, we get 30. So that's okay. If the carry is set, which it's not, then oh, but that's why the carry isn't set, because so it keeps flipping modes back and forth. Okay, that makes sense. I guess the question is, do we really need to be doing this? Probably not. We probably don't need to be doing this here because we've eliminated a lot of the logic that was kind of flipping back and forth between the different rows. The only time we would want to do that is if we subtract the 8 here. Yeah, I'm good with taking this out. All right. Let's take a look at the memory here now. Really just let me disable the breakpoint. I want to see what it's actually doing to the memory here, if it's actually going to update. No, it's just updating the same rows still. Did I not reload the ROM or rebuild the ROM? So we're incrementing the attribute index. And then at the end, we're saying, okay, subtract. All right, let's take a look at this with the debugger back on. So value is 40 hex, so we're going to subtract our 16 and we're going to get 30, which is good. And the carry is set, which is what we want because we don't want to switch modes yet. So now we're going to step over and branch, and we're going to update the memory. And then we hit it again. Let's take a look at the name table. So step over, and we're going to load the value 8. Why is the value 8? It shouldn't have been. Oh, I never stored. That's why. We need to store that in case we're not flipping modes. Okay. So that would make a difference. First value we're going to have is 40, that's fine. And then 38, that looks better. 30. Okay, that's looking like what I expected it to look like finally. And now the colors all look right so far. Oh, that's not right there. But otherwise, that's actually correct. That's excellent. That's what it's supposed to be doing. So we have that one issue with the one row there not getting its updates. But otherwise, that looks exactly right. Now, it's likely that that update is, or that problem is actually happening over and over again. And we just don't see it because it just happens to align properly. Okay, so it's this half update. I wonder if we need to update this to... I wonder if we need to update this not to be 30. Let me think about that. If we're in split mode, we do want to start at 38. We don't need to do that anymore. I don't think that's what's causing the problem, but let's take a look here. Just let me make sure that I really rebuilt that. So it's just, it looks like it's just on split mode when we roll over, that it's not updating that attribute row properly. Store attribute mode. Compare it to split. this code is junk at this point. Do we use this anywhere? Yep. And that's our scroll for the status bar. That's our PPU copy of the attribute memory. See you later, Skidyet. Thanks for watching. And all right. Ah, so close here. Are we for some reason running into a situation where the index is getting the wrong one? Am I confusing my conditions here? Let's see. So for no split mode, we're updating the entire row at the top here, starting at 0. So we get to 0, 8. And then we get to this point and we say, okay, we have 8. We have 8, and then we're subtracting 16, which gives us F8, and then F8 with an AND of 3F gives us 38. Maybe we don't even have to do that modification, that special condition for the indexing here. But let's see, so when we do the subtract, our carry will still be set. The carry will be clear. We've stored the attribute index as 38. So because the carry is clear, then we need to flip the bits in attribute mode. Let me think about that. So if we're in split mode, we'll have been... Oh, wait a minute. I think I know. I think this actually needs to be 0. Because the first... Let me think about that. This update would be... No. Nope, never mind. That doesn't need to be 0. This whole meta tile row gets updated, and then... Well, let's kind of watch this in action here. I missed it. It's unfortunate, but it looks like the only time we have that problem is in that one initial update, because that's the only time we have the blue tiles in that portion of the screen. And then everywhere else, it's updating the attributes and the meta tiles properly. So that's a half meta tile row update. Wait a minute. I think I might be thinking about this slightly wrong. So we're currently in split mode, and this is fine. And we're going to get to the top of the screen, and we're going to go out of split mode, and that's when we're going to have the problem. So when we get to the top of this meta tile, we're still in split mode. So we're going to update row 0 with the attributes and the top row with the attributes of the meta tiles that we're loading. Maybe we're not updating. Yeah, it looks like we might not be updating the meta tile, the attributes of them. Okay, that's what it looks like. So what it looks like is when we're hitting this row here in the name table, pause, damn you. When we're hitting this row in the name table, that's half a meta tile row that we're loading. But we should be updating the attributes for this top set of tiles. Oh, and then this top set of tiles also. Okay, right. That's what I remember from 2 streams ago, maybe? I remember thinking about that and saying, well, let's get the rest of this working and then we'll worry about that. Okay, so that's not that big a deal. That's actually, that's good. That means we're basically done if I can fix this problem. So what we're going to do is we're going to subtract 8 and we're going to do our AND, right? And then we're going to say branch carry clear, branch carry set to no, I want to do, how do I want to do this? Branch of the carry is set to avoid mask change, which this is avoid mask change. So basically what we need to do is we need to I wonder if carry is still set here. I feel like it should be. And then basically we say, okay, branch if the carry is set to skip mask change. And that's this part here. Basically what we have to do if the carry is set, then we've rolled over to the bottom of the attribute table and we need to invert our masks, our bit masks here, the F0 and the 0F. Could we do that using variable? Maybe. Let's do this with logic here and then we'll worry about reducing the code and the branching. So otherwise what we're going to do is we're going to do AND 0F stored in temp2 load the attribute. This is, I can just feel myself being like, yeah, this is we don't need to be doing it this way, but let's just get this. Let's get this working, and then we can optimize this, because this is just obviously wrong that we're doing exactly the same code with just the flipped bit masks. Which, I mean, that part, the logic of why we're doing that, I believe is right, but the way we're doing it is suboptimal. So, and given how often this is going to be called, I really want this to be working properly. And then the problem went away, which means we fixed it, which means our attributes are working. Nice. All right, so that's exciting. Let's do this. So, how do we do this in an intelligent way? Basically, what we need to do is, if we roll over from the last row in split mode, the problem is that we're spanning the name table, right? So this is the problem with doing horizontal scrolling like this, is that we are sometimes going to be scrolling through the name table, and we're going to update half the attribute row up here and half the attribute row down here. And the issue is what we've talked about before with the way that the tiles are laid out. So this is 32 tiles and this is only 30. So the lower attribute update, you need to update the, if you update the upper bits of the attribute tile like you would with any other part of the attributes, it doesn't, wait, did I reverse that? What I'm saying is correct, but I want to make sure I've got the right position in the bits going here. So yeah, so what we would be doing is we'd be updating the bottommost bits here and then the topmost bits on the bottom. But the problem is that the topmost bits on the bottom are meaningless, because this whole row of tiles don't exist. They're not there, right? So what we actually have to do is 2 updates of the effectively the lower 4 bits, right? Which means we have to do what we're doing here, which is kind of stupid. So is there a better way to do that with the current, let's see. What I really want to avoid is this branch, because it's unnecessary. I'd like to just be able to modify, just flip what we're doing in terms of the masking. I mean, we could just make another, we can make another variable. Well, I mean, the other problem is that our code is still exhibiting that jitter in the status bar, and that's because we are taking a little bit too long here. Although one thing I just realized the other day when I was thinking about this is that we could probably get away with this if we started our timer at the beginning of the NMI instead of the end of the NMI like we're doing, so that it's not dependent on the length of our NMI routine here. Let's do that. Let's move that so that the timer is always firing off at the beginning, so that it's not dependent on what we're doing in the NMI, and then the jitter goes away. Now, to be fair, we're still taking too long, because you'll see that we're going to get, you know, in the 2700s, but at least it makes that jitter on the status bar go away. And we can spend time optimizing this later. That's actually reasonable. That's all working. Okay, I'm fairly happy with that, because now our attribute updates are happening properly. We should see the green tiles at the top of the level now. And this is by no means the end of working on this, but it's good enough for now in that we can, yeah, there are the green meta tiles. Cool. All right, so that's actually working. So the attribute stuff is working enough that we can work with it as is. We're going to have to probably change it around because of the amount of data we're using to store the attribute rows encoded in the level data, because I was thinking about how all that works, and while it's good not to have to look up that data, at the same point we're wasting, you know, data that we could be using for level data for these attribute updates. And we could look up what the index is of this palette, of this meta tile, based on the palettes that are loaded pretty easily. So something to come back to. There's also the issue that we talked about with the fact that we're not caching the lookups into our meta tiles. We're effectively looking up the position into the meta tile every time. So we find the meta tile every time we draw a new row, and we don't have to do that. We only have to look for the meta tile for each of these positions once per meta tile row, and that would probably speed things up a little bit, because we don't need to be redoing those calculations every loop. We can do them, you know, just once in a while, so that it only hits us with every meta tile update, like we're doing with the attribute updates. But I actually want to switch gears here for a second and go look at MESEN. I also want to, not that, I want to also look at the build settings for the NES. So what I had done was I had made some changes, or I had set up a build process for NES here in Sublime Text, so that I could just do Control B to make it build the code. And where the hell is that? So new build system is, okay, so let me close that. It's just a file, I guess. That was so long ago now, I don't even remember. Packages. Oh, is it in my local preferences? What I want to do, here it is. What I want to do is, okay, so it's just using make, and then I have a make file here. Is that what I've got? Okay. So I want to update my make file for it to generate debug information for MESEN, which is, let's see, just //debug or debug info --debug info. Okay. Does that create a separate? So that's my object file. Obviously, I haven't looked into this too much, but what you can do is you can export your debug information and then use that for, and then use that for MESEN's debugger so you can see your symbols. So debug file shooter.debug, let's just say. Okay, so that, oh, that created the file. All right, cool. And it's not empty. That's also good. All right, so we can close this. Let's go to MESEN and run it. And then let's go into the debugger. Disassembly options, break options. Now I know they were saying when they were talking about this yesterday, you can load in the debug symbol file, assembler, PPU. It's a logger. Because if I can load my symbols, that would be amazing, because then I can really see what's going on. State debugger. I imagine it would be right here in the debugger workspace. Oh, import labels. Oh my god. Oh, that's so good. Oh man, that's gonna make things so much more easy. So wow, so this is loading all of my labels and my variables, and holy cow. Okay. Wow. Okay. So this is running. So let me reopen the binary, because I don't know if it's cached like an old version of it or something. No, I guess the palette that it uses is different. It's very dark palette viewer. Yeah, it looks like the palettes are right. They're just much darker than FCEUX. But anyway, holy cow, that is amazing. So you can see that the sprites are wrong here. And from what I would guess, it's because the way we're using MMC3, we're not loading the registers properly. Does this actually know about the registers for the mapper? So like we set the mirroring here, store A into A0. No, okay. So that's the issue we have right now, which is that if you look at the name table, that's all good. If you look at the character ROM, the background is partially okay. I mean, that seems good, although it's got a repeat where in FCEUX, if we look at it, if we compare, you can see it's not quite the same. And for the sprite memory over here, for the sprite char ROM, it's not correct at all. And I expect that it looks like that's because, so that's the PPU 0 to 1 FFF. And that's the char ROM 0 to 1 FFF. Interesting. So I guess the question is, how do I get MMC3 to change what it's looking at? Because right now it's not the right thing. And that's me assuming that that's what the problem is. It may not be. Oh, I'm starting the game up in FCEUX and there's no sprite or anything. And I was like, what's going on? So let's see. So this sprite, these sprites are... That's so weird. So it's looking at this part here, it looks like, which is that's probably the right offset for the tile, but it's not the it's definitely not the right actual graphics there. Well, let's see. Is there anything that would help me figure this out? Event viewer, what does that have? Oh. Wow, okay. So is this showing me when things are happening in the time frame? Oh, really? So what is that? I have to look at what that duration actually represents. What is the yellow squiggle? What is that? PPU register writes. Wow, that's really cool. So it's like actually showing some sort of profiling of the PPU. Huh. What I really want to see though, oh, you can write, really, you can write arbitrary code in here? Wow, okay. I wish I knew about this a lot sooner. What I'd really like to be able to see is if there's anything related to the mappers. Doesn't look like it. Run one cycle, scan, assembler, okay. Increase speed. Just curious to see if the colors look right throughout the whole thing, even though they're the darker colors. I'm okay with that. I just want to make sure we get the green tiles at the top correctly. Well, sort of. Looks like we're not getting the... Again, it's something with the mapper not being updated properly for the way that these charom banks are set up. So this is... something that I find sort of confusing in the way that the documentation is written, because the way it's explained is not obvious to me, at least. Specify which bank register to update on next write to bank data register. But of course, they don't tell you what bank data, what a data register is. This is, let's see, program bank mode. 8 swappable, C fixed to second to last bank. Or C swappable, 8 fixed to last bank. So we're at, our code is starting at E0. If we go way back to the beginning. So our beginning is at 8 E0. Program bank mode. CPU 8K bank fixed to the last bank, which is where we are. That's where our code lives, which is at the end of the memory range, which is good because that's where we need to put our vectors for reset and NMI and the IRQ at the end, so that's fine. And then for the PPU, it has 2K switchable, another 2K switchable, another 1K switchable. So it's got all this memory that's switchable at those ranges. And what it looks like is happening is we're only seeing the first however many bytes of memory that are here. So that's 7F. It's 127, and each tile is what? Each tile is 4 bytes, 8 bytes, 8 bytes, right? It's that dual plane mode, or are they 16? 16 bytes. That's not hex 16, that's 16. So that's 2K. Sort of, more or less. So that's our 2K switchable there, right? And then there's another 2K, but I wonder if it's, I wonder if it thinks it's the, I wonder if it's referencing the same tile set there. Let's see, can I mess with that in the debugger here? Should be able to. We can get to the bottom of how the hell this works. Alright, so in the CPU memory, if I go to 8000, that's the register for how we tell the MMC3 mapper what it is we actually want to do. So we want to change the prog-rom, sorry, the char-rom bank, where we want to select the second char-rom bank. So that's the value 1. And then I guess we then write a secondary value into 8001 to tell it which bank we want. Like, I don't understand these tables. They were clearly written by someone who understood it completely and had never tried to explain it to anybody before. It's like a college textbook. Or I'm just not reading it carefully. Who knows? Memory mapping and scanline counting. So we want the memory mapping portion, and 8000 is for bank select. 8001 is for bank data. This is for mirroring, that's for program. Okay, so is it just non-consistent naming? So bank data is actually what they're talking about. Okay, so they didn't call it the data register, they just called it bank data there. Okay, so the new bank value, based on the last value written to the bank select register. So an 8000... and the last bit is set, so I don't care about that because not interested in that. So R0 and FE. What are R0 and R1? Are they talking about register 0 and 1? What's R2? I will definitely do, once I figure this out, I will definitely do a 0-page episode on this, because I could see someone who doesn't, who's not very technical looking at this and just being like, what the hell am I looking at right now? So I just want to try and set bank, select 2K character bank. So I want to select the second range of tiles. Let's see, that would be address 800, starting roughly, where would that be? 800, right here. So I want to change that. So I want to, so what, 01, 01, does that do anything? Do I have to select the emulator for that to, or has that completely crashed? Do anything? No. No. I'm not seeing any changes to the banks. I don't know if this actually impacts the emulated device directly, immediately, or if this is... So, I mean, I should be, in theory, be able to change because the values in R6, 7, and 8000 are unspecified. To power on, the reset vector must point to E1000 FFFF, and the code must initialize these before jumping out of there. So when 8040, which is 124, which is the 124, yeah. Oh no, sorry, wrong set of bits. So P, program bank mode. So like if I do 044000, that change anything? Doesn't seem to be. My code still seems to be running. Reset the game here. Is there a way to see for sure that this is, so it's using mapper 4, 32K of that, so 8K of that, no work RAM, none of that stuff. That all looks right. Okay, so mapper 4, that's what MMC3 is, right? Mapper 4, okay. So, I mean, in theory, what I should be seeing is that if I update the memory, I should be seeing changes to what the code looks like if I do it correctly. So like if I set 40 and then, I don't know, 01, this would bank swap. Oh, at 8,000. Well, I don't really have any code there, but I mean, that says unidentified blocks. Let's see. I just don't think this is actually doing anything, because I don't see any updates to the PPU viewer. Can I in assembly, can I do that there? Like if I load A with 00 and then store A in 8000 and then load A 01 and store A in 8001. CPU until a write to 3000 is performed. Oh, that did change that. Okay. So that's better. CPU will not resume its normal execution until a write to 3000 is performed, or at least the last line of code is reached. This will assemble and execute the code. Store A 3000. Okay. So that does seem to be okay. That is changing the banks now. that's exciting. So we want that to be 0. And then I guess what we want is the next bank to be 1. Like we just want to lay it out linearly here. No? Where is this? So 0 chooses that, and then 2, sorry, bit, that's bit, oh no, those are the values. So then 1 is select 2 kilobyte char bank at, and then select 1 char bank. Let's just mess around with this here, because I really have no idea. Oh, wait a minute. No wonder it's not changing anything. I'm writing to 8,000 and then 8,000. There we go. So then okay, that looks more like what we expect to that's what we're seeing in FCEUX. Okay, so now that looks like that's the sprite char ROM. So okay, now we're getting somewhere. Now we're actually starting to see some of what we expect. Should I be writing this to this location? It's weird. Why is it incrementing? Oh, does it? I wonder. Is it looping around? It is. It looks like it is. Why would that be? Hold on a second. Let me reset this because it's a little screwy right now. Where's the actual debugger screen, or the actual emulator screen here? Okay, start the game over. What I want to do is I want to just see if I can understand how these registers work. So if I'm setting this like this, it's not doing what I expected, but if I change this to this, and then I run it, that updated that bank. And then if I update this again, will it switch back? Okay, so that controls that charrom bank that we want to change. So that's that one, but we don't care about that one. We actually want to change the next one also to reflect. Okay, so that's good. And then this one would update, I think, the sprite charrom, except that we want to have it have the actual sprite data in it. And oops, what happened? Assembler, where'd you go? What's this? This? Oh, my code is gone. Oh man. Load A 8000. I can't remember what the value was. 4. Store A 8000. Load A. Store A 8001. Store A 3000 to make it jump back properly. Oh, well, that's weird. Why did it change? Because I thought this was 1 and 1. I guess I need to really look at the... It's so weird. It seems like it's actually like looping through the... It's almost like it's looping through and updating the banks in like an order rather than allowing you to set them directly. And every time you do it, you're setting up the next one. So it's almost like if I restart the NES here, if I write, it's a 2K, let's say I want it to be a 2K, just a 2K charrom bank, so it's 0, and I want it to be bank 0. And then the next one, I want that to be bank 1. That didn't do anything. And then the next one, bank 2. So that seems to have now hit that one. And then the next one, I say bank 2. It should be the same thing, but in that spot. Is it like doing it in this order? So 1, 2, 3, 4, 5, and then 6. No, those are the different banks. That's so strange. Some examples would be nice. Scanline counter. Scanline. IRQs. MS3 has 4 pairs of registers. Select the low register, and the odd address selects the high register in each pair. These can be broken into 2 independent functional units: memory mapping, scanline counting. I'm going to have to do some research on this and come back to it for the next stream on Thursday. But what I can say is that, you know, now that we've got MESEN running and the symbol files loaded, holy crap, this is going to be so much easier to work with to be able to actually see our code and labels and everything working with all of the names that I've given things, even if not everybody agrees with my label capitalization. But one thing I was wondering is if there's a way to change. I feel like there's got to be a way to change the palette. This is so much darker. You know, it's probably an emulation. Nope. There's a palette viewer here, and you can click on it to change it. But that, while that's useful, that's not exactly what I was looking for here. Well, anyway, we don't have to do this now. We've had a pretty long stream, but you know, we got the attribute stuff working correctly, so that's cool. Probably need to do some optimization related to the way the NMI is running, but it's actually not too bad all in all. I'm pretty happy with the fact that we got it working, and the palettes are updating properly, and yeah, I just messed with the register here, so that's all. But you know, our colors, ignoring the ignoring my sprite problem with the mapper not working properly, the colors are updating properly, and the status bar is not jittering, and we can spawn our bad guys still and delete them, and things are not horribly slow or laggy, so that's pretty cool. I think now we just need to start working on actually, well, I got to do some research on MMC3 and figure out why the hell it's loading the wrong sprites into the char-rom here, and then once we fix that, we'll start working on collision with these tiles and maybe optimizing the level data a little bit. So pretty cool, got that working. That was exciting, and MESEN is really cool. We'll probably be using that moving forward for our debugging, because damn, that's awesome. Look at this, it even has my comments. I feel like there's a ton of stuff we need to investigate about how MESEN works and what it can do to help us out. So anyway, as always, I'm going to post the recording of this on YouTube, and we'll be streaming on Thursday at 9 Eastern. If you have any questions, you can find me on Twitter at Clairvis. You can post comments and questions on the recording on YouTube. I try to get to that pretty quickly. And I'm on Nintendo Age in the forums and the Discord. And hopefully I'll see you Thursday. Thanks for watching, and I'll see you next time.